My name is David Alexander. I work for Regency IT Consulting, which is part of Cassidian. I am the SCADA Capability Manager for Cassidian and Head of Vulnerability Research for Regency. I am responsible for our SCADA research and development and delivery to clients. And I've been doing this for about 3 years now, I guess, when I first started on the SCADA elements of it. So I've got about 20 years background in information security. Industrial control systems are the kind of things that use process control feedback loops. So it's things like oil and gas, water distribution, electricity distribution, all this kind of thing, manufacturing systems. So the kind of systems that actually run machinery, run refineries, nuclear reactors, all that kind of stuff. They're very different in the way that they're designed and built to sort of standard enterprise networks that we run office systems on. They go back to the 1770s. James Watt, the steam engine, was the first industrial control system, the steam governor he put on these devices. The first electrical system was actually signalling on the railways in the 1840s. And it's not till the 1950s that we actually get to serial devices and valves actually being used to put in what we would think of now as industrial control systems. And that's, of course, well before we had any kind of networks that enterprises are using. That's part of the problem. A lot of these systems are legacy systems. They're designed to last 15 or 20 years. A lot of them are still based on protocols that were proprietary and made by the different manufacturers of the control systems. So you can go to an organization now and find they've got 5 or 6 different manufacturers' equipment in place, each of which uses its own protocol. And trying to secure that lot is extremely challenging. Also, the kind of networks, some of them, whilst a lot of them are now running over TCP/IP, standard fiber or copper interfaces, some of them are still using old serial connections because they just work, they're reliable, and the people don't want to replace something that isn't broken. So being able to defend both the modern digital control systems that people are now starting to put in, along with the systems that have been in place for 20 years, you have this huge temporal gap, and there is no one simple solution that fits everything. So you have to have a capability to defend the modern systems and something that can defend the older systems and that can work side by side and still feed up into a single reporting mechanism. That's why it gets so difficult. And trying to put this kind of architecture in place, because these systems, they're designed to be reliable and they're designed to be what's called deterministic, so that the information all arrives in the right sequence, because of course the sequence things happens to is critical. But the problem is that they've got nothing to do with confidentiality at all. So there's nothing about authentication, there's nothing about encryption, there's nothing to stop me from injecting new traffic or replaying old traffic. So actually confidentiality is something that back in when control systems were first developed had no interest to them whatsoever. All this stuff was air-gapped. It was literally blokes in brown coats with clipboards stood in front of banks of controls and switches, and it wasn't connected to anything else. So it didn't matter. Now it does, because business is saying we need to have systems that are connected to the enterprise. For our enterprise resource planning, we need to understand what production is happening. We need to understand what we have, what performance is like. So these systems are now linked into the business domain, which of course means that the business domain is connected to the internet. And in turn, that means that the control systems are now vulnerable to attack, plus all the other attack paths like USBs and laptops and dial-up connections and so on, because you have remote support. The companies want a single control center that can monitor everything from around the world. So you have this remote access capability, you have this regional control. If I can compromise that regional control center, I can compromise assets across maybe half a dozen different countries. And if I can get in through the remote access from outside, I can attack from anywhere else on the planet, just as I can with any kind of a standard enterprise network. So coming up with an architecture and technical means that can defend these things, especially when the protocols they're using aren't the same kind of ones that are being used in enterprise networks. So the kind of firewalls and intrusion detection systems that work for a standard commercial enterprise don't work in industrial control. You need specialist devices. And you have to have all this understanding, and you have to be able to make sure that everything you're doing works reliably and doesn't have an adverse impact on the control systems. Because of course, if they're running a refinery, when you look at things like Buncefield, that explosion happened because their industrial control systems failed. Nuclear reactors, of course, these kind of things are safety critical. You can't have an adverse impact.